So on the bottom of page 6, tree diagrams. It's a systematic way in this case to find all subsets. I'll bet you guys have seen tree diagrams before. You know what I'm talking about? So the first question that we're going to ask in this tree diagram, we're trying to list all the subsets of set A, B. We're going to say, is A an element? And if it is, of the subset, we will say yes, or we will say no. Is A a subset? Either yes or no. Well, yes. So if A is an element of the subset and it's yes, then we branch off and answer this next question. Is B an element of a subset? So it may be yes or it may be no. So we go from A is in there and B is in there. And that would result in the subset A was in there, B was in there, and the set AB is a subset. We could answer yes to A is in there, but then we could branch off and answer no, that B is not in there, and that will result in which subset? Yes for A, no for B would be the subset containing A. We could say no to A being in there and yes to B being in there. What subset would we build that doesn't have A but does have B? Does that make sense? To me, this is more confusing than just listing them all individually. But we want to do tree diagrams for the future because sometimes tree diagrams will help us with probability questions. We could say no, that A doesn't live in a subset, and we could say no, that B doesn't live in the subset, and that will result in what subset? Done. Remember, you can write empty set like that, or you can write empty set like this, but don't put the set of empty set. Don't put that in there, one or the other, but just not both. It might be easier just to list them instead of using the tree diagram, but that's another technique to systematically find them all and list them all. Now remember what we talked about yesterday. All of these are subsets. These are special subsets. They're called proper subsets. Any subset that's not itself is said to be proper. So this one has 4 subsets and 3 proper subsets. Let's see if we can recognize a pattern.
Why is there only 3 proper? Doesn't the no subset make that?
Yep. So 1, 2, 3. There's just 2 different ways of listing it. No, for proper subsets, it's got to be a subset and not itself. So this one is not a proper subset. They're all subsets, so there's 4 subsets, but only 3 of them are proper. Up here, when we had 3 elements, we got 1, 2, 3, 4, 5, 6, 7, 8 subsets. 3 elements resulted in 8 subsets. All 7 of these were proper. Just itself is just a subset, but it's not proper. Okay? 8 subsets, 7 proper subsets. There's always one less proper subsets because you can't include the set that includes itself. Okay, so if there are 3 elements in the original set, how many subsets can we build? That's the one that we just looked at. When there's 3 elements, 1, 2, 3. How many subsets can you build? 8. When there's 2 elements in the original set, we just did that one. How many subsets can you build? 4. When there's 1 element in the original, let's say it's a set that contains the number 10. How many subsets can you build out of that? The subset that contains 10, and what's the other one? The empty set. So you can only build 2 subsets if the original set has only 1 element. And how many subsets can you make if the original one has 0 elements in it? The original set has 0 elements in it, so the original set is the empty set. How many subsets does the empty set have? 1. Okay. Now let's talk about proper subsets. A proper subset is any subset other than itself. So how many proper subsets? If there are 8 regular subsets, how many proper subsets can there be? 1 less than that. How about 4 regular subsets? How many propers? 2, 1. The empty set doesn't have any proper subsets because the only subset of the empty set is itself, which is not proper. Get it? Anybody see a pattern here? How are the number of original elements, the cardinality of the original set, how is it related to the number of subsets that it can form? As the number of elements increases by 1, the number of subsets, can you think of that word? What? Doubles. It doubles. Can anybody come up with the pattern of its doubling? Doubling. The number of subsets with n elements is, the number of subsets with n elements is, anybody got it? Yes, the power thing. It's the power thing. Is 2 to the nth power. So if the number of elements is 0, 2 to the 0 is 1. If the number of elements in the original is 3, 2 to the third is 8. So this is our magic machine. It doesn't give you the subsets, it just gives you the quantity of subsets that you're going to have. What's a formula for proper subsets? It's the number of regular subsets minus 1, because it can't have itself as a subset. Why is it 1 less? The subset that it's itself the subset that it's itself, or the subset that is equal to the original set, is not proper. How do you feel about that? That's why there's 1 less. And so now, we're not trying to list all of the subsets. We just want to know the number of subsets that we can have. the number of proper and the number of regular. So this has, count the elements, 3. The cardinality, or the number of elements that A contains, is 3. That's n. The number of subsets is 2 to the nth. In this case, 2 to the third, which is 8. Is that okay? The number of proper subsets is 1 less than this, 7. You guys try part B. Count up the cardinality, figure out how many elements are in there. Remember, if there's ever a repetition of one of the elements, don't count it twice. And once you figure out how many elements you have, use the formula. The number of subsets is, anyone? Did you get this one already? 1, 2, 3, 4, 5, 6. 2 to the 6th, or 64. If I told you that there were 64 different subsets, thankfully we don't have to write them all down. That would be a nightmare. How many proper subsets is there? Every subset works except for itself. Is that okay? Anybody have any questions about that?